Good afternoon. Well, last time we finished the security. We studied how an organization can be protected using VPN, etc. Basically, that is the end of the security part. Today we will be looking at switching. We will start with a little revision of diploma. After that, discuss more on the VLAN. You can write main heading. Layer 2 switching. Layer 2 switching. Our topic is virtual LAN. The switching we will derive from what we learned in the diploma. Okay. Already we have defined switching as a layer 2 function. And you also know that the layer 2 has frame, not packet. Layer 2 has frame. And for the Ethernet, the frame is using a MAC address, remember? Physical address or a MAC address, and based on the MAC address it will be switched. Frames will be switched from a computer to computer. We are not talking about a network layer now. We are talking about the layer 2. We will quickly mention that. Initial revision on this. Layer 2. Called the frame. Frame. Each frame carries the MAC address. MAC address is like a physical address. Layer 2 switch. Layer 2 switch. Use the MAC address. To send the frame to the correct destination. To the correct destination. We do a little bit of what we went through in the diploma. We said layer 2 switch is also called an intermediate system. Router is also intermediate, switch is also an intermediate system. What are the things we have learned in the diploma about this? Are there different methods of switching? To and forward. To and forward is one method. Cut through is another method. Mainly those two actually. Cut through will not analyze the body of the frame. It will just look at the header, quickly analyze the destination MAC address and forward it to the output port. Other bits will be just copied from the input port to the output. For revision, we will quickly go through them. You may remember this kind of a diagram where the switch will not allow collision. Switch will not allow collision. But if we take a device like a hub, it might cause collision to happen. But layer 2 fitting is a function which will minimize, which will avoid. Also you may remember, switches can be connected to the hub like this. One port of switch you can take it to a hub and then distribute. But then this area, this port will be one collision domain. Each port will be one collision domain, but whole switch was one broadcast domain. Whole switch was one broadcast domain, but each port was a collision domain. We write that also in our summary. These things we are not going to discuss, right? We are just summarizing. And they hope that you have remembered them from this one. Okay, right? In a bridge, this is like a switch. Switch is a theoretical name, right? Switch. Each port is a separate collision domain. Each port is a separate collision domain. Collision domain. However, all the ports are in a single broadcast domain. Underline broadcast domain. That means if the packet comes or frame comes with the broadcast address, it will be okay to all the ports. Then functions we will make functions of the layer 2 switch. In the diploma we studied 3 functions. We will make the same 3. This one was creation of the collision domain, because each port is a collision domain. Create the number of collision domains as we need by using a switch. Second, full duplex operation. Wire transmitting, you can receive. That is called full duplex data transfer capability. Third one, anyone of you remember? Any questions from diploma? This is, I am giving you the diploma not again. Maybe you notice. That was the third one when you can. Study 3 functions. And that is the third one is one we have studied in detail in the advanced. That was creation of VLAN. So that is the topic for the advanced system. Other two actually we have finished discussing in system. This we did to some extent, but we have to extend now. Creation of virtual LAN. creation of collision domains I will just skip because we have done this earlier. The company having multiple departments like accounting, engineering, any other, all of them are in the same method originated by the engineering computer to another engineering computer. It is going all the way and logging the bandwidth of the whole company. A better method would have been that we regionalize it so that we will understand that it is a local communication here, so we will not forward that packet to the other side. So that means the bandwidth here will be saved. It will not be wasted due to this community. So that was the whole idea. So that the bandwidth in different parts of the company in your wiring can be saved by using this. Okay. You don't need to go there, we have drawn it already. The concept developed initially, idea for source routing came, but no more now. Transparent concept came after that. Concept developed from source routing to transparent. Although the word routing is used here, it is not routing, it is switching. Because at that time the words were not that clear. People use various words. But today we use only this, so you can put a tick for this. Transparent switches. What do you mean by transparent? Transparent means even if you install this, it is basically plug and play. That means this will program itself. So routing has typical outdated now. Transparent bridges main feature is self-learning. How does it self-learn the configuration? Firstly, we will mention there is no manual configuration to be done. These are plug and play type devices. You can build the switching table by allowing the packets to pass through the network. While it allows the packet to go through, it learns. We know routers we have to configure, ports and other things we have to program. But switches we don't have that problem because switches are very special self-learning capabilities. Routers also do, but still some configuration should be done. So this is because the switches have a standard algorithm called IEEE 802.1b, which is known as STU. Spanning tree algorithm. Right? Switches use IEEE 802.1b here is not 2.1b spanning tree algorithm. Spanning tree algorithm. To build the decision tree. To build the decision tree of how to forward packets, how to forward frame. Decision tree of how to forward the frame over the network, frames over the network. And then frame arrays, you know, there was to and forward method which show the whole thing and then analyze and then send. And there is a cut through method which will analyze only the head. We mentioned about that also. Switching methods you can mention. Method. Cut through, go and forward, fragment tree. Out of that, put a tick to the cut through. So that is the more popular. To the cut through. There is some little sentence on your own about cut through. Others you don't need to describe. Just describe cut through mode in your own sentence. But basically I mentioned is when packet arrives, here error will be analyzed, decision will be made, and then rest of the packet, rest of the frame actually will be just forwarded to the output port. It will not be analyzed at all. You are not storing all. You are not storing. The body of the frame will never be stored. It will be just copied from one to the other. You can put that in your own words. That's really good. There will be analyzed, decision is made, other bits will be just copied to the output port without storing it. But header you have to store because analysis needs storage. Is that easy, right? After you wrote your sentences, you can read again. Assume that you are the examiner now. Read it again. See whether you get the meaning. You can read assuming that you are not the one who wrote it. Double check whether it carries the meaning. It has the meaning that header is entered, stored, analyzed, decision is made. Other bits of the frame are just copies from input code to the output code. Now is the time to take your own sentences and be correct with them. For this time you have to get ready. So the notes you write, you can read and double check at the same time. And be satisfied with what you are writing, right? Hope those spelling mistakes kind of problems we have overcome right now. Because we are in the advanced system. Second is very serious on spelling now in the advanced diploma. They are actually serious on grammar and spelling in this level. They have been asked to do that by the CEI because you are getting extension from the CEI. Part 1. Part 1 has a lot of papers for writing and they are giving you extension once you pass this. So CEI has requested to go through all that. Again, you have objected. They are now discussing whether to continue their relationship or not. But for this year, they are still having their agreement. So that means the marking will be built up like this. So grammar and spelling will be seriously dealt with. So if you are, I think we mentioned that in the diploma. I hope you have overcome your weaknesses, otherwise within the remaining time try to do something about it because no one else can do anything about it other than you. Spelling and grammar, it will not be, we can't do it now here also. It has to be individual attempt. Then best way is you read it and see whether the grammar is okay, spelling has been a mistake. That's why I asked you to read. Okay, now this method has a higher throughput but increased chance of error. Higher throughput means more participants is placed in the unit time. But because you are not checking the errors in the body, these errors can occur. So yes, it has higher throughput. However, there is an increased chance of error. Then go and forward switch. You may remember that it will accept the whole pattern, show it, analyze, can catch pattern errors even within the body, and if it is having error, it will stop, it will not forward it. If there is no error, then only it is forwarding to the destination. The accuracy is better. But delay because you have to store the whole thing and then analyze it. And you can summarize like this. But we all know that today's videos are mainly cut to design. Then we will study STA in this little more detail. And write STA spanning tree algorithm. We will go example like example. These graph lines are local area network. For simplicity, the computers connected to the lines are not shown. Only they are joining features are. And what is land A? Land A. Land B. Land C. Land D. Land E. just mentioned, but as I mentioned, PCs in each line are not shown. PCs in each line. PCs in each line are not shown. For simplicity. Let us assume that computer in this line is sending a frame to line E. What are the possible paths? It can go through this bridge 1, bridge 6 and come here. Or it can go through bridge 2 and bridge 5 and come here. Or it can go through bridge 3, 4 and 5 and come here. There are 3 paths. If all the bridges are self-learning type, then they would have learned this configuration quickly. And therefore, a packet which is originated here, addressed to the computer there, will come in replicate. Same packet will come 3 times because other bridges will also forward. The problem is, only one arrival will be enough, but there will be 3 arrivals. The bridges are doing too much, isn't it? Doing too much. All of them are to support you, so they all think it is their responsibility to forward. So you will get 3 copies. But you don't want 3 copies from that computer. That's the problem. That is why we need an algorithm, so that only 1 copy will come. Can you write about this idea? Okay. It's a example. It's a PC in line A. It's a PC in line A. Hence the frame to a PC in line E. Hence the frame to a PC in line capital E. Assuming all are self-learning bridges. The packet will, the frame will arrive in replicate. The frame will arrive in replicate 3 times. Replicate. Can you write down the path? Number 1, 2, 3 like that. You can mention via which bridge. So it will be 2, then with 5, 2, 5. 30, 3 plus 3, then 4, then 5. 3, 4, 5. happens because of the looping. There are closed loops when you look at the net. It happens. Due to the problem of loop. STA, spanning tree algorithm, is a logical method to eliminate this loop. Logical. Why do we say logical? Because it does not physically switch off any bridge. All bridges are there. It will identify a logical route on other route, additional routes, it will put into standby. So the route is there, but you put it into the standby. In case the main route fails, other route will work. That's why we call it logical method. Because you don't switch off any physical. Some switches maybe you can switch off. Maybe this you can switch off. Because the packet could be delivered anyway. You could have switched it off. But STA will not do that. STA will not switch off anything. It will identify primary routes, others it will put as standby. So there will be only one route identified, others are all standby. Example, single route, ROUT will be identified from line capital A to capital E. Capital A to capital E. So, other route will be put on to standby. Other routes will be route ROUT. Other routes will be put into standby. Underline standby. Standby route will be used only when main route is not available. Then how does it happen? The bridges, first of all, we will need the bridges to be able to talk to each other, so that they will learn from each other what are the best routes. Just like the routers. For the routers to talk to other routers, they have a routing protocol. Same way, we need bridging protocol. Bridge protocol data units will have to be interchanged between bridges to learn between them. And right? It is necessary to have bridge to bridge communication. bridge-to-bridge communication, to achieve this. The bridges exchange BPDU, bridge protocol data unit. BPDU in bridge protocol data unit. Between them. BPDU consists of BPDU contains following. Following information. A, part A, the current root bridge ROOT now. Root bridge. I'll explain what is the root bridge. Then B, the distance to the root. Again ROOT. In hop. HOPS. Hop means how many other bridges you have to pass. Number 3, part C, bridge address. D, part D, the age of the information. Age means how old is this information. Age of the information. Those are the four types of things that they interchange. Root bridge is like the head. There are several bridges and they will elect one bridge as root bridge. They select a procedure and extend it. So then all others will calculate how many bridges it has to jump over to go to the root. And that information is being passed between each other. So that others who get the BPDU can recalculate. If there is an error in their decision making, they can recalculate. Just like the routing, you cannot. Routers also did the same thing. Suppose the routing link fails, the other routers will quickly inform each other. We discussed distance vector method and link state routing method. Same way here, for bridges to talk to the other bridges, there is a protocol. This time we can call it routing protocol. So what do we call it? It is known as STP. Because our algorithm is STA, spanning tree algorithm, there is a spanning tree protocol. According to that protocol, there are these BPDUs defined and they carry these four information. So using them, each bridge will recalculate its decision table. Right? Each bridge will use this information to calculate the current vertical spanning tree of the network and then keep it in the memory. Keep it in its memory. Keep it in its memory. This happens using STP. This happens using STP, scanning tree protocol. This bridge communication is done like that, and the root bridge will have to be erected by the other bridges, from all the bridges, by looking at their serial. The bridge which is having the smallest number, serial number, will be automatically selected as a root. Okay, what is science say? A root bridge is elected as the one having the smallest serial number. So each bridge has a priority number combined with the bridge MAC address. So this is how it happens. When you are electing a road, each serial number should be broadcast by each bridge is now serial numbers of other bridge. And then everybody will identify the bridge having the lowest serial. And that will automatically be elected as the road bridge. And then by using BPDUs, each one will calculate what is the shortest hop. How many hops will have to be there to reach the root, and the root will be forwarding to each of the other destinations. That's the method. That's the convention. Maybe you can write just a summary will write like this. Serial number broadcast by each root. need to span all the local area network, but not all the bridges. Some bridges you can put into span that it may not be active. Just do an example. Bridge 1 is the root. Bridge 1 is the root. Now draw the spanning tree. Draw the spanning tree. So shall we draw? Plan A was our example. This one is the root bridge. And if the hop count is to be minimum from land A to any other land, what are the bridges you should put on standby, what are the bridges you will be using? So back to that diagram and draw it. Land A to any other land. That means bridge 1 is the root. Bridge 1 is the root. You can redraw it by identifying which are the bridges which need to be erected, which are the bridges that should be on the standby. Use of terms. This one will be there because it's a root bridge. So you should draw the is now okay. Can be reached. And from here this can be directly reached with one hop. It can be directly reached with one hop, and it is on standby. Nothing. So put this on standby by a symbol or anything. Or even if you don't draw it, it is fine. It is on standby. And what about this? You put this, you disable this because the root bridge will forward it with one hop. Normally you erect wire root bridge. Right? So this one again disable. Disable means not physically but logically you are not using it. When you go like that, you can see there are no loops now. Loops have been eliminated, and it is just like a tree from the root. That is why it is called spanning tree algorithm. The branches are spanning from the root. tree of shortest path within bracket hops from the root to every other bridge, from the root to every other bridge is constructed. Now all loops are eliminated. Also important to understand this. It is dynamic. That means every 1 to 4 seconds, the users will talk to each other and double check. So the topology is not changed. Supposing someone switches off the root, then others will have to re-elect another root. The next serial number, next priority root will be becoming the root base. Put a assignment. This is a dynamic protocol because it checks the topology. Because it checks the topology at regular intervals of time. Checks the topology at regular intervals of time. Method every 1 to 4 seconds. If topology changes, if topology has changed, spanning tree will be recalculated. Spanning tree will be recalculated. Using the result on standby as well. Using the results on standby as well. Those bridges in standby will not be switched off because they are, that's why they are called standby. If there is any link failure or some power failure or something in a particular bridge, quickly they will recalculate the spanning. So it's a dynamic protocol, just like routing. So bridges are also intelligent devices, we cannot. How do we get the plug and play capability for a bridge? Suppose we remove one switch from the LAN and put a different switch. How will the new switch know the configuration of the topology of the network without you programming? Self-learning capability, how is that? When a bridge is plugged in, initially it does not know where are each of these computers. There may be several ports. And it does not know which port is connected to which computer. So if a frame comes with a destination address, what will it do? From one port it comes. But you don't know where the destination computer is. So what are you supposed to do now?
Broadcast it to every port.
Yes, broadcast it to every port. then you are sure, you know that it must be somewhere connected, therefore you will broadcast it to every port. So then correct computer will get it. At the same time, because you want to learn now, you will note down the port through which the frame came and the source address of the frame. The source must be there, source computer must be there in that port for you to send that frame. So you will enter that into your table. Okay, this particular computer is now in that port. So likewise, it will continue. If it is not sure, it will broadcast. If it is sure, it will put it onto that particular port. So that way, within a short time, it can learn where each computer is. So after that, it will not broadcast. After that, it knows exactly to what port every computer has been connected. Then it will switch to the correct port on. So for a short time after you plug in, there will be learning operation. During that time there can be broadcast, but after that it will settle down. So that's one level of intelligence in the figure. Second level of intelligence is using FCA. They will be calculating the spanning tree and preventing the loops occurring in the network. So even if the topology changes or somebody switches off the switch, it will still adhere. Network will still adhere. That is called convergence. Network will reconverge to a new spanning tree. So self-learning. I would like you to write, but let us discuss again to double check whether you have a good idea. Initially when you plug a router, plug a bridge into the net LAN, it will not know the topology. So when a packet arrives, it will note down the source address and the port, but broadcast it to all the ports. That way, within a short time, it can build a list of computers and the port it is connected. So after that, it will not broadcast, it will switch onto the rest. So supposing the examiner asks us to explain this. Examiner asks us to explain this, then we make a try. Now that we have the idea, we will individually make a try to explain this self-learning capability. In other words, it's plug and play capability of the bridge. Plug and play capability of the bridge. That's why we call them transparent. Transparent means it will not disturb anyone and silently program itself. That's called transparent. So think clearly first and then start writing. sometimes you do this more for the exam also. When there is a question and you don't know the proper answer, you will broadcast whatever you know. You will write whatever you know, thinking that it might answer maybe somewhere inside. Let the examiner find it. But that kind of trick will not work with the physics paper, right? So you write again read for yourself. Read as the examiner. Read as if someone who did not know and check whether anything is like not clear. Check whether the meaning is not clear. Check for spelling also. Think of the idea is not complicated. Idea is when you plug into the system, topology is not known. Therefore, it goes into that mode. and any incoming packet will be broadcast to all ports, while making a note of source address and the port number. So after a little while, list of source addresses and the port numbers are built up. And then he comes out of this promise first mode and starts switching. That's the idea. So idea-wise it is not complicated, but when you are writing, lots of problems can occur, right? So if you are capable of self-detecting them, that will be really good. Is right and then read like a exam. Read as if you are not the one who wrote it. It is that you are asked to mark this, and how many marks will you give out of 10? Put yourself into that mode. It's like the Prometheus mode, that is different mode of taking. Put yourself into that mode and then read. Then you can catch your own mistake. That is the way to do it. Not only for the exam, it is always good practice to have that. Not only for the exam, even in the job. If you are the one who finds your own fault, you become a very good worker. It is a way of, it is actually an attitude. Some people have the attitude that, okay, I will do it in my way, let the others find fault. And if the work find the fault, fine. If he does not find the fault, fine. If he finds the fault, well, he will blame me, it's okay. That's an attitude. Just check whether you have that attitude. It's not a good one to have, right? Yes. We sometimes have that attitude. Like, I do it my way. I don't care what happens. Let the others find the fault. If there is any problem, let them find and tell me. Have you done any work like that? No doubt you have done. I have done myself. Right? Sometimes we do. Because we have other priorities. We sometimes do the jobs like that. But the problem is, it becomes a practice. That attitude becomes a practice, and after that, you want other people to find your fault. And other people are not that kind. Every time they find your fault, they will punish you. That's what the examiner is also going to do if we find a mistake. But only way to correct this is like this. We judge ourselves before others judge us. Because the only person who will be kind to you is yourself. So let that person find it first. Then that person will kindly advise you, okay, this is the way to correct. And that person is inside you. So let that person read just like an examiner and then find the faults for you. And after that you can try the next one with correction. Not only for exam, even for the job. Think of the people in your office who are like that, who do, when you give a job to them, you are sure that it will get done. Do you have people like that in the office? Reliable people? Every office has. Every office has one or two reliable people where other people believe that if he does the job, he will make it good. Others have that feeling. How does that come? It doesn't come automatically. It comes like this. They have practiced it this way. Before others judge them, they have judged themselves and corrected. So they become good employees. Usually they are the ones to get the promotion. Usually. Sometimes unlucky people are there. They do hard work but don't get promotion. Right? But most of the time, those are the people who judge themselves are the ones who climb in the organization. So think about this. If you carry that attitude of, okay, let the others find my fault, of course they will, but they will be too harsh on you. They will make your life harder later. if your boss finds, he might cut one or two increments from you, or he might blame you, he might cut the bonus, or he might even fire you sometimes. So they are too hard. Before they fine, you must fine. That should be there. It's a good way to, maybe within the next month, if you can be on that attitude, you can achieve a lot towards the exam. Get the past papers and write them. Later read it, they are in the examiner's hat. And examiner's hat means if you read it once, if you don't get the idea first time, you don't read it again. You reduce the marks and decide, okay, this is how much I give it. So assume that you are the examiner, read it, and then you will see how good you are or how poor you are. And then you can improve. That's how good students normally learn, or learn or practice for the exam. This is not easy to do. Not easy to do. You can try it once or twice, and initially it is hard. Initially it is hard because if you carry that attitude, it's very hard to adjust. But only for a short time you will experience it. After that, it will be very, very useful attitude for you. Very useful attitude. Suppose, for example, suppose your boss says from tomorrow you don't need to sign the register, attendance register. Would you be happy? You don't need to sign in or out, you can plan your own work, and I will give you independence, but I want the job to be done. That's the only thing I am worried. Do you like that or not? Normally people like that, isn't it? So then you are more free. You are more free, and you can come at any time and go at any time. But normally your boss don't say that. Why? Most of the companies, section head will not say that. Why don't they say that? Because most people don't have that attitude I mentioned. Most people don't have the attitude of self-correcting, self-examining. Section heads normally know that, therefore they don't put that role. But if there are people who are having that attitude, whether that rule is there or not, it does not matter. It does not matter because anyway the job will be done. So that is how it should happen. That's how you must climb in the company ladder. Those who are employed and are in the company will understand what I am saying better. Right? So the problem of getting people to sign and then sign off makes them more into that attitude of letting the others find the fault. If you are in such a company who wants you to sign in, sign out, then definitely you have that attitude that let the others find my fault. I am signing in, doing my job and going home. That's all. So that practice itself trains slowly into that bad habit. So, be careful, right? Be careful with that kind of companies who insist that you work only 8 hours and vanish after that, because that will slowly train you towards that attitude. I have been in workplaces like that, and I saw myself not improving also during that time. Then I have been in places where I am not asked to sign. When I was at Rupani, I was not required to sign, and university I am not required to sign anywhere. I am free to plan my own work. But what I find is that I do more hard work than those earlier places, because I think I just feel that it's an obligation to self-correct myself because they have trusted me. And then slowly it improves yourself. It improves yourself, take the responsibility. This just what I just mentioned is a good starting point. When the company is not supporting like that, you can start your own little way to develop that attitude, and slowly you can be your own judge. Now that exam is coming close, we are using it as an exam technique actually. But why I mentioned this is because it is not only an exam technique. It is even bigger technique. We call them techniques of personal improvement. Some companies provide training, like outbound training. How many of your companies have outbound training? Anyone who has gone for outbound training? Nobody. Therefore, it is provided, I am sure. Have you gone? Not yet. So, in the outbound training, one of the techniques is this. If you go for outbound training for a week, for a few days, they normally ask you to do a job and ask you to mark the job also, rate the job, and ask someone else to mark it, and you are asked to compare and learn out of it. So these are normally done in personal improvement workshops. They sometimes call it positive thinking workshops. Various names are there, but companies call them outbound training. Outbound means they take you out of the office and put you into a training somewhere else, which is a complete different surrounding, and train you for these various attitude changes. Not skill change, but attitude change. Someday you will have a chance of going where so many companies do it today. Then keep these ideas in mind because you will be doing that. Okay. Coming back to this. Next subject we have to move in. Now, so far we have been doing mainly revision because this STA, STP kind of thing is deeply studied in the diploma. Then our main focus now in the advanced diploma is virtual lab, virtual local area. You can write mainly subheading virtual lab. Virtual local area. We know that the conventional switch, if it is not a VLAN switch, it will not support you to limit the broadcast. So if a packet comes with a broadcast address from one port, it will be copied to all other ports. But VLAN switches allow you to divide the broadcast domain also within the same switch. So some ports you can group into one broadcast domain, some other ports to different broadcast domain, right? If it is not a VLAN switch, it is only having collision domain, single broadcast. If it is a VLAN switch, it can have collision domain and the broadcast domain, both programmable, definable by the user. So we write the conventional switch. Does not limit the broadcast domain. Does not limit the broadcast domain. All stations belong to a broadcaster. The VLAN switch allows the port ports to be grouped into multiple broadcast domains. Underline that sentence. So that is the specialty in a VLAN switch. And that means it has to maintain two tables. One table for switching, other table for this VLAN table and a switching table. Next paragraph. Therefore, VLAN switch maintains the VLAN table. VLAN table in addition to the normal switching table. Underline VLAN table. That table identify the port. That table identify the port for each VLAN. Identify the port for each VLAN. Within brackets configured by the network administrator. Configured by the network administrator, which is not hardwired, programmable by the administrator. For example, take a 3 volt switch just for simplicity. This is the station. You can mention your port 1 and port 2 belong to this VLAN, which is called blue VLAN. Port 3 belongs to red VLAN. Blue and red are just the two names we give. Any names can be given. So you prepare a table like this, which is programmable by the administrator. So he is grouping the ports to different broadcast domains. Take one broadcast domain here. That means that consists of port 1 and port 2. Port 3 is a separate broadcast domain. But how many collision domains are there? 3 collision domains, 2 broadcast domains. Earlier we learned that a router normally have a broadcast domain. Router is the one normally defining broadcast domain. But now VLAN can do that as well. Broadcast domain can be done using layer 2 MAC address or port. So you can go this simple example. Advantage is to have a second VLAN switch. This VLAN can be extended into that door. Blue VLAN can have some stations connected to second VLAN switch also. That means VLAN switches can be connected to other VLAN switches by using a technique called VLAN trunking. We will draw another diagram for trunking later. So you can go install. So what we mean by VLAN table is this. You can just have a look at this, don't write this. Now that we have two VLANs in our earlier script, if we issue a ping command from station 1 to station 2, what is happening? Will it reflect? Ping command from station 1 to station 2. It will, because 1 and 2 are in the same VLAN. If we issue a ping from S1 to station 1 to station 3, no reflect. Because it is in a different local area network. Not physically, but virtually it is in a different local area network. If it is not different VLAN, it will also reflect. So that is what will practically happen. If the ping is issued from S1 to S2, S2 will reply successful. S2 will reply successful. Reason is your broadcast will be heard by S2. Ping will be a broadcast and it will be heard. However, ping from S1 to S3 will not be successful. S1 to S3 will not be successful because that broadcast will not reach S3. If you want that to be successful, you need a router. Only routers can interconnect VLAN. Therefore, VLANs need routers to interconnect them. Need routers to interconnect them. Because now they are separate broadcast domains. Suppose distributed VLAN. Distributed VLAN. Distributed means there can be more than one VLAN switch, and some computers will be of a VLAN will be connected to one switch. Some other computers may be connected to a different switch, but still they can be in the same way. That kind of a thing we call distributed VLAN. Let us see an example. Two switches now. Switch 1, switch 2. This is a trunking port. This is a VLAN trunk. Now you can group different computers here into VLANs and ULANs. For example, S1, S2 and S5 you can group into one VLAN. And S3, S4, S7, S8 you can group into different VLANs. Right? That's called distributed because physically they are distributed but logically they are in the same broadcast service. Can right? A VLAN can span over any switches. First you can draw it like this. Just for example, we have a group it here. Next we prepare a table to group this. when we color it like this, suppose I want S1, S4, S8 blue. S1, S4 and S8 you can color by blue. S1, S4, S8. Those stations we want into one broadcaster. Physically they are in maybe two different rooms. It may be in the engineering division of the company. It may be in finance division. Suppose we put the people into a group, we can say S1, S4 and S8. S1, S4, S8, we put into one broadcaster. Then others you can put into red. S2, S3, S5, S6, S7. Color them red. Then we will prepare VLAN tables now. This is VLAN table for switch table 1. The switch 1. This is the table for switch 2. We will prepare the two tables now. Earlier we prepared only one for one switch. Now because there are two switches, each switch having 5 ports. Blue, red, like that, otherwise you can identify. Port number 5 is a special port. Did you notice this port? What is the color of this port? Both blue and red, because the computers are here and there. The tagging means color. Identified by the color, they have to go to this port number 5 here and port number 1 there, all of them. Therefore, when you enter port number 5 into your table, you have to mention that port 5 belongs to both VLANs, red as well as blue. And that kind of a port we call a tagged port. Other ports are not tagged, they are directly connected to station. Note how that particular port is described in the table. You can highlight this tag port in your table. So when one VLAN switch is connected to another VLAN switch by this kind of a trunk, we call this a trunk, then we have to tag those ports. Can you mark this line as a VLAN trunk? here you can say VLAN trunk. This middle line you can mark like this. You can write port 5 of switch 1. Port 1 of switch 2. Are configured as test port. TAGGED, test port. So the frame transmitted through this port. This port should be set. Should be set. TAGGED, set. The set will identify the channel. Set will identify the channel. What does this mean? One VLAN trunk, this is a trunk port now, one VLAN trunk will carry multiple channels. Here in this case 2 channels. The VLAN trunk is a multi-channel pipe. Right? Therefore VLAN trunk is a multi-channel connection. You can imagine it like this. This is a switch 1, switch 2. Then this is the trunk. In the trunk, blue frames as well as red frames must go. But in other one, only one side will be there. They are not trunk. That's the difference. It's a multi-channel pipe, in this case 2 channels, because there are 2 VLANs here. And we can just draw it like this. This is the imagination. The way to imagine that the trunk can carry multiple colors. So multiple stacked frames. Because the red VLAN computers are here as well as here, they should be sent there to the trunk. Blue ones are also distributed, therefore blue ones should also go to the trunk. a frame is coming with a red head, it should be going only to the red computer. Let's see then envelope. Yes. But that means the frame will have additional information here, the tag. So there must be a standard in order to do the tagging. Otherwise, the other VLAN will not, other switch will not know to what port these different tag frames should be forward. So there must be a standard. Okay, note that the trunk is a multi-channel. The trunk is a multi-channel inter-switch connection. The trunk is a multi-channel inter-switch connection. Multi-channel inter-switch connection. Underline yes. So we'll look at the tagging after the break. We have a break and we will discuss what is the tagging stand.